right? This is the one in book. In the book, it says, so get data is a procedure to get the radius, and area is to calculate the area. Then circumference is to calculate the circumference. So likewise, so there's 3 procedures basically. You can see 3 procedures inside that. And you can use these 3 procedures, right, to get information about, or to call the procedures to run this. This is the code in the book. I'm going to run this. And when I run this, the first procedure is called. The first procedure is to get the data. It's asking, okay, it's asking, so I have a few local variables not used. So let's remove those local variables, right? Unused variables. I'm going to remove that unused variables, and now I'm going to run this. Now you can see the first thing is it's asking, according to the first procedure, get data procedure, it's asking the radius. Then I'm given radius as 14. It will calculate area and it will calculate circumference. So that is by calling the second 2 procedures. Procedures can be called to get something done, and functions can be called to get something done, but the result can be stored after running the function. That's the difference. So please write down the difference properly in your note. You can take a screenshot of this also, or I'll send the code to you. So this is the code, you can try. I'm not going to give you time because now almost it's 9:20. Right, we have to discuss more. Right, okay. So let's move. And now you know the difference between function and, right, now you know the difference between the basic function, right, and procedure. So yes, you can, if you want, you can take the screenshots. That is okay, totally okay, no issue. But anyhow, you have to be honest. Try this along, understand. That is what I really want, because so unlike other live classes, so maybe unlike other video classes or live classes, so we are trying to get the maximum benefit of this by doing the practical simultaneously. That means I'm waiting until you do the practicals and I'm correcting your codes. Likewise, real time, we are doing this together as a teamwork. So keep that momentum, move. So please try this alone and get the results. That is the expectation of this class. Otherwise, if you just by heart the things, read the note and by heart and go to the exam, that is like useless. Because programming, you can't do that. So again, I'm telling, if you really love programming, there are 2 courses with us. So that is a teen programmer, as well as there's another program called junior ICT programmer and the teen programmer. So there we will be covering most of the programming aspects like web-based programming and application development, database related programming and advanced programming concepts, and stretch programming, how to do animation, how to program a game. Likewise, many things are there. If you really like to learn programming, you can join in that class and learn further. But if you don't love programming, don't select that. So that is totally up to you. Okay, so then function and procedure we have learned. And next thing that, so here anyway, these functions and procedures. So both, these are the common features, and procedures can be called, any number of times during the program execution. That will reduce code replication or repetitive works. The function or procedure can be called again and again during the same program. So since you can call this again and again, you don't want to write the code again and again because you can call it. Call again, call again, call again. Only thing that you have to do is call it again. So similar to this, here you have get get data, area, and circumference. So again, if you want to do this, you can get data again, and then you can find the area again. So if you want to get data again, you can again do get data. And if you want to find this time, if you want to find the circumference, you can find the circumference. Likewise, you can do this several times in any order. So let's run this. Now this code, oh, what has happened? Get data, get data. You have to call, so here you have to give the radius, and here also you have to give the radius. Okay, so when you run this, you can see it's asking the radius first time. First radius is 14. It gives the circumference and the area. Second radius, let's say 21. Again, it gives circumference. The area is given, not circumference. The next one I'm going to give like, okay, let's say 28. So it gives the area, circumference and area first on circumference. Likewise, I can call the function again and again and get the results without rewriting the code above. මේ උඩ තියෙන කෝඩ් එක ආයෙ ලියන්නේ නැතුව මේකම කෝල් කරන්න පුළුවන්. ඒ නම් වලින් you can call it again and again. Function is like, or procedure is like lunch. When you take lunch, when you say lunch, so all the elements in the lunch එකේ තියෙන ඔක්කොම අත හොදලා කෑම බෙදාගෙන කාලා ඉඳුල් ටික අයින් කරලා ආපහු අත හොදගෙන එන තැනට එනකම්ම lunch. Right? Everything is lunch. So when you tell lunch, so you can just call, when you call lunch, everything will happen. Similar to that, when you call by the name, everything under that will happen. That is the advantage of having these functions and procedures. Okay, the next one in your book. So we learn about functions and procedures, yes. So next one is the need of programming languages. Let's go to the theoretical part of this lesson. So why we need a programming language? So we discussed this initially, but let me remind this again quickly, right? I'm going to remind this quickly again. So basically machines can understand machine language. So if you want to turn on bulb, what you should do? If you want to turn on the bulb in your room, what you should do? Yes? If you want to turn on light in your room, what you should do? Akash? කවුරු හරි කියන්න බලන්න මොකද කරන්න ඕන? බල්බ් එකක් on කරගන්න ඕන.
Turn on the switch.
Turn on the switch. That's all. Simple as that. That is the instruction which can be understood by the bulb. Turn on the switch. That is the instruction which can be understood by the bulb. So that is called machine language. Simple as that. Machine can understand machine language. When you give current, it will turn on. When you cut the current, it will turn off. So basically, these are represented by using two-state logic called binary. So one means presence, zero means absence. Presence of the current, absence of the current. Presence of the current, absence of the current. Presence, absence, presence, absence, presence, absence. So likewise, you feed instruction to the computer or any computing device or any electronic device. So then you can get the work done. That is the easiest way of telling something to the electronic device. But it depends on the machine. Bulb එකට දෙන instruction එක washing machine එකට දෙන්න බෑ. The instruction you give to the washing machine cannot be given to the air conditioner. The instruction you are giving to the air conditioner cannot be given to TV or radio. You have to change it. That is machine dependent. That is called machine dependent. So machine language is represented using binaries, and anyway you feed instructions on the computer, input devices, through input devices, that will go to the main memory. Main memory will send it to the CPU for understanding. CPU will execute that and give you the result through the main memory. as output, which will be displayed in the monitor. So this is the entire process. We learned this in grade 10. When you input something as data instruction, input devices will capture that and it will go to the main memory. Main memory will capture that, will send to the CPU. CPU will calculate, send it back to the main memory. Then main memory will again deliver this to output and then to the monitor. So that is the process. Right, machine language, no, you don't have a website. So machine language is everywhere, right? So let's connect. So I'll suggest this one. I'll suggest this one. So if you want, I'll suggest this one, machine language, try karanna. Okay, I'll suggest this circuit construction kit. Machine language is raw, right? It's raw. It's a raw format. Language it's a raw format. Basically, you give power and control that using switches. If you want to learn machine language, learn electronics. That's all. Right? Machine language means simply you have the battery. This is a very simple version of machine language. And using a switch, you can instruct what to do to this bulb, whether to turn on the bulb or turn off the bulb. So this is called machine language. Simple as that. Okay. So the first state says, okay, අපි නම් මේක first one is මේ පළවෙනි switch එක නැත්නම් පළවෙනි sensor එක. It's indicating this is night. රැයට තමයි මේ switch එක දාන්න ඕන. අපි හිතමු මේ රැය. මේ ඇවිල්ලා so if අපි හිතමු රැයට මේ bulb එක දාන්න ඕන. රැය දෙවෙනි switch එකෙන් බලන්නේ තව logic එක. That is basically before 10 p.m. Before 10 p.m. අපි හිතනවා after 10 p.m. everyone is sleeping කියලා. ඉතින් 10 p.m. වලට කලින් නම් දෙවෙනි එක දානවා. Then you can see the bulb is on. It's 1 means 1 here. So this is AND gate and this is what really machine language is. Simple instruction. So this is to just, you can play this game, right? This is circuit construction kit. And you can just play this as a game. So you can try this. I'll send the link. You can just try that. Okay, so anyway, machine language is basically instructions in raw format where machines can understand this. So we call machine language. Instruction in raw format where machines can understand. Here you can see, could be executed directly on the machine. It's fast. No need of translating because machines can understand that. It's machine dependent and difficult to understand by humans because it uses zeros and ones. It's represented using ones and zeros, presence and absence. So everything, even a graphic is presented using 1 0. Even a song is presented using 1 0. Even arithmetic presented using 1 0. Characters represented using 1 0. So people cannot understand this. It's very difficult, not cannot. So here, Manusek Hitiyot, so he will try. It's very difficult to him to understand this. Right? It's very difficult to him to understand this. So this is called machine language. He's upset because he cannot understand. But if it is a machine will definitely love this because machine can understand this very well. No need of translators even. So machine will love this. So machine will happy to have the machine language. If you want, just you can draw this art, but in pencil, right? So here it's not, machine is happy. If you want, so you can draw this, but using pencil. Right? Don't draw this in pen. Machines will love this, people will hate this. Simply because machine language is so difficult to understand by human beings, no translator needed, depending on machines, but fast and understandable by machines. So then the assembly language. Okay, hope you understood this, right? The concept of machine language. Okay, let's move on. then the assembly language. Assembly language means you assemble the machine code. Assemble means you merge the machine code. Assume that you have something addition වලට තියෙන machine code එක මේක කියලා හිතන්න. Then register 5 is shown using 101. Let's say register 10 is shown using 1010. So if this is a machine code, what is done by the assembly make this easier by representing this using some English letters. So let's say R5 is the register 5 and R5, I'm going to add this to R10. So this is the assembly code, right? Assembly will represent this binary using this, but to translate this binary code, to translate this assembler code to binary, you need assembler. There's a translator which is required to translate this code. So that is about the assembly language. You can just write it there and show. Right, okay. Then you can see, you can guess, right? You can guess what happened in the machine when you give this kind of code. So machines won't love this code much. So do the people, because it's intermediate language. But you need something called assembler to translate this language. Assembler is used to translate. This is slower than the machine language. So these are the key points to remember. Slower than machine language, need to be translated. The assembler is used to translate this. It depends on machine again. Symbols, use of symbols. So I have given the same example. So this example is true, right? This example, something similar to this. Add register 1, register 10. Something similar to this will be given in assembly. Assembly code you can learn using some language, right? So if you want to find a website to write assembly code, I think you can go to the same website, this one, and learn assembly. I'm not sure. Right, let's say write assembly online. Yeah, you have ASM compiler and online GDB also supporting GCC assembler. Right? You have different programs, different interface, different. Here, this one, you can write the assembly. See here, make a balance. Make the assembly language. You can write code there. Right? But it's not really understandable, but somewhat okay. Somewhat you can manage. So this is assembly. You can write the assembly and train yourself. Assembly is also important. So if you want to learn hacking, right? If you want to learn hacking one day, I advise it's better to learn assembly, because so whatever you write will be first translated to assembly and then translated to machine language. So that is the nature of the machines. Here you can see this in the book. First level is hardware, that is machine language. Second level is assembly language, and then you have high level languages. Etora high level languages වලින් තමයි software හැම හදන්නේ. Software හදන්නේ high level languages වලින්. ඒවා assembly language එකට translate වෙලා තමයි computer එකට යන්නේ. ඔයාලට පුළුවන් නම් assembly ඉගෙන ගන්න. ඔය ගොඩක් හැබැයි මේක හොඳ දෙයක් නෙවෙයි මම කියන්නේ. Crackers ලා එහෙම පාවිච්චි කරනවා. එතකොට high level එක assembly එකට ගියාම මේ assembly එකේදී අර high level එකේ තරම් secure නැහැ. assembly එක දන්න කෙනෙකුට එහාට මෙහාට කරලා මේක අර register නොකර පාවිච්චි කරන්න, tracks හදන්න, track කරනවා කියන්නේ software. genuine නැති software අරගෙන ඔරට software අරගෙන track කරන්න ඕනේ. they tracks හදන්නේ මේ level එකේ වැඩ කරන්නේ. And hacking can be done in this level because then the top level is visible to everyone. The protection in top level is high, but protection in the second level is quite low. So you can hack in this level. So that is using assembly language, quite difficult to learn. It's not easy, right? There are some games having hack mode, APKs also. APKs means like, so we have like different that is application extension, right? So in games, basically there are patches and all for mobiles. There are patches and all. So these patches and tracks, basically those are created by trackers and hackers. So mostly they use assembly code. Mostly they are using assembly code. You can just check. Okay, the third level, high level programming languages. So we are in this level. Actually, we are using high level languages in our day-to-day life. So in the high level languages, basically those are the Pascal, COBOL, Pascal, C, C++ like languages. And those are actually, people are happy about this. Even you are unhappy, I know. Even you all are unhappy to learn Pascal, but all people, they will love this. Why? So they can, now they don't want to learn this assembly and machine language, which is really, really, really hard. But these languages, people love this, but machines, pathetic. Machines cannot understand anything at all. Poor machines cannot understand anything. So they don't love, they hate. Cannot understand anything. But there's the friend of this machine. There are two friends who can convert this high level to machine language. Those are called translators. There are two types of translators. Today we are going to learn that as well, because I said that in the beginning of this lesson. But again, I'm going to remember that. Can anyone remember those two translators? Yes. Can anyone remember those two translators which translate high level language to machine language? Anyone? Or no one? කාට හරි මතකද දැන් අපි පැස්කල් වලත් පාවිච්චි කරේ එහෙම එකක්. ඔන්ලයින් පැස්කල් ඊට පස්සේ හිස්තනක් තිබ්බ මොකක්ද? What is that? Okay, compiler, yes. One is compiler and the second one is interpreter. So the difference between these, what is the difference? Interpreter and compiler difference? What's the difference? Interpreter and compiler. What is the difference between both? Okay, compiler translate all at once, whereas interpreter translate line by line. Then Pascal code එකේ error එකක් තිබුණොත්, right? Pascal code එකේ එක තැනක error එකක් තිබ්බොත් code එක run වෙනවද? Is it running? Pascal code එකේ එක තැනක error එකක් තිබ්බොත් code එක run වෙනවද? නෑ. මුළු code එකම run වෙන්නේ නෑ. ඒ තමයි compiler වල හැටි. හැබැයි මම වෙන language එකක් පෙන්නන්න. මේක ඔයාලගේ syllabus එකේ නැහැ. ඒත් මම පෙන්නන්නම්කෝ. දැන් මෙයාලා මේ code එක දන්නේ නැහැ. ඒ වුණාට මම ලියලා පෙන්නන්නම්. ඒක අමාරු නෑ. මේ Python තියෙනවා A level ICT වලට. ඔන්නෝගොල්ලෝ ලියන්න කැමති නම් එන්න Python කියලා දෙන්නම් ඇඬෙන්න. හරි. Python වල සෑහෙන දේවල් කරන්න පුළුවන්. Security, hacking ගොඩක් දේවල් වලට ඕන වෙනවා. මේ වෙද්දි popularම language එකක්. ඒක A level වලට තියෙනවා. ඔයගොල්ලෝ වාසනාවන්තයි A level ICT කරොත් ඉගෙන ගන්න පුළුවන් Python. හැබැයි මට මතකයි මම Python ඉගෙන ගත්තේ masters එක කරද්දි. පශ්චාත්තුපාදය කරද්දි තමයි අපිට Python තිබ්බේ. ඉතින් ඔයගොල්ලෝ වාසනාවන්තයි ඔයගොල්ලන්ට A level වලදී Python තියෙනවා. master research එකට තමයි Python use කරේ. Python R we have used in master research. But ඔයගොල්ලෝ ඇත්තටම ඔයගොල්ලෝ lucky ඔයගොල්ලන්ට පුළුවන් ඊට ගොඩ කාලයකට කලින් ඉගෙන ගන්න. right? Let's say x equals this. See how simple this language is, right? X equal 5, y equal 10. So then you can say print x plus y. So let's say print x into I. I'm going to print x minus y. So you can find the error here. What is the error? You can see the error now. What is the error? No, I have not paused the screen, Pute. Can't you see my screen?
Can't, sir.
Can't.
Also, it's still in the textbook.
Oh, still in the textbook.
Yes, sir. I think some problem.
Okay, wait.
It happened in the grade 10 class also.
Yeah, that's, I think, some issue. It was happened in that class also, no?
Yeah.
Wait till I happen, right? Wait till I change the screen after stopping, right? Let's stop.